All results.
All right. Okay. All right. So in last class, we described some of the future or ongoing development of additive manufacturing, and one is the multi-additive process. Another one is the combination of additive process plus the subtractive ones, right? So we mentioned this application. Actually, we described this when we talk about the LOM process, right? So so basically, it combines the LOM process plus the color printing, such that you could make some full color objects. And another process is this laser. So basically, it's a combination of two different SLA process. One is laser-based, another one is projection-based. Basically, the idea is using the two process, using the combination of the two process to build those objects with large areas. And because the laser-based ones usually has better resolution or surface finishing on the built part. At the same time, the projection-based one has a more efficient process compared to the laser one. So how about to combine the two together, such that for the contour part, use the laser-based SLA, but for the interior part, use the projection-based SLA process. So it turns out there will be the hybrid process by utilizing the two process. And here, this shows a possible implementation of this process. So I would like you to have some little discussion on this kind of process. What could be the problems, and what do you think about the combination of the two?
Maybe not so much a problem, but I'd say this being very quick. It can probably be very fast.
Yeah.
You know, because you can have your laser do a lot of your detail work.
Yeah.
Then you have the actual projector doing kind of like bulk.
Mm-hmm. Mm-hmm. Right.
Are you the controls of it?
Mm-hmm.
You're controlling two different heads that are looking at it two different ways.
I can worry about alignment.
Alignment.
Yeah.
Control and alignment. Yeah. These are actually the challenging points to implement this system. And also, I don't remember who mentioned that in last class. So how about the interface between the area generated by the two methods, right? How about which part is generated using the projection-based, and which part is generated using laser? How about the one joining the two parts together? Whether there will be some problems. One possible problem is the overcuring. That means you will cure the area both by the laser-based and the projection-based. And that will make your layer thickness inconsistent. That could bring the problems when you add up all the layers together and make your material property non-homogeneous. So actually, this is a research work done by my friend, who's a professor, assistant professor at University of Buffalo. What he did is basically he kind of make a buffer region in between of the two layers, and using the he defined this region such that the overcured area will be minimized, and for this region, he will do a laser scanning in the last step of the process, such that it could avoid the overcured case. But again, it's not guaranteed. right? Because it really depends on how large this buffer region is, right, in between of the two regions.
A lot of the
Yeah.
vendors sell a
Yeah.
post-processing where you cure it.
Yeah.
UV afterwards. Does this have the potential to
Yeah.
eliminate the post-processing?
Mhm.
Still would be coded, but, and we have
Yeah.
one of those, I mean,
Mhm.
we have an SLA that's just all laser,
Yeah.
even all laser, we still have to do the UV.
Yeah, it still requires the same post-processing. I don't think it will avoid the post-processing. So yeah, I think you're going to do the same thing to the part. The only point is for the building process, it could save time. And at the same time, maintain some high quality for the surface finish.
A little slower than the field, like projection.
Exactly.
But
Yeah.
they've got good edge.
Yeah, that's the case. Basically, it's kind of a interpolation of the DLP plus a laser base. Some idea like this.
So does the post curing go like all the way through the part, or is that really just treating the surface? When we're talking about putting in the UV
Oh,
lamp afterwards?
Definitely does not go all the way through the part. So that
Mhm.
crack open.
Who's camera?
Oh, it's like a
That's a
bubble
selling
gum with a gummy center.
yeah.
There you go, bubble gum.
But
Do they change size? You know, like when water freezes, it grows. Do they change size when they cure?
yes, it is.
So he could run into an issue like if he's putting the contour first with the laser,
Mhm.
and the inside second.
Yeah.
That could grow and break his contour.
Yeah, that's true. That's true. So that requires some calibration and testing. So by doing some testing, you will understand what will be the behavior of the material during the process, such that you could adjust your algorithms. So that's why is all these kind of algorithm, you have to have a very good testing bed. You need to tweak all the setup in your algorithm based on the experiment.
Does
So-
it matter which one goes?
Pardon?
Does it matter which one goes?
Well, I think,
You don't want it to crack.
yeah,
What I
Does it
described,
matter if
you
you
do the-
project
I think
first?
you would do the.
You do the inside first, then, and then you do the contour on the outside.
yeah, that's the thing.
It's magic. Yeah, I would imagine if you're doing them separately, you're losing all your advantage of having this simultaneous hybrid type process.
No, but the lasers don't move.
Yeah, lasers.
But actually
Pretty quickly though.
the projection is pretty fast.
Yeah.
So you can do that first and then do the laser. Basically, you reduce the scan of laser. Yeah, that's the case. You can think about the projection is instantaneous. kind
Yeah,
of
but
like
I think the hard part of it, I think that the thing that we discussed a minute ago about the alignment causes you to think it might be easier to do the laser first. If you want the two layers, if you want the laser edge
Mhm.
to
okay.
totally always be the outer edge, you do it first and then you hit it with the inner. That way, if there's a little bit of overlap,
Mhm.
it's only a little. But if you hit it with the light, if you hit it with the inner first and then your laser is slightly off from that,
Mhm.
it may or may not be creating an edge.
Yeah, you may have.
So your point is yeah.
Sorry.
Yeah, so your point is kind of, okay, if there's something not looking good, let it inside. Not on the contour. Well, yeah, that's a good point actually. But for the paper, I think he did the interior first and then do the boundary.
And I'm always, I'm still always amazed how accurate that we can make systems nowadays be with their, and then how fast they move. So,
Yeah.
I don't think that's a huge hurdle.
Yeah.
So did he have, is that like a printhead type thing that he's using to scan the laser? Because it doesn't seem to have an optic.
I think that is maybe.
Cayenne.
I know, that's what I was.
See? Yeah, here is yeah, there is one.
It doesn't seem to show.
I think in this
It
one.
might be in that.
Yeah.
shake your head.
I think
This is maybe a different
yeah.
process.
Yeah.
I think in this figure it just it's not there on top of there. But for this one, you can see it has a layer to do the process. And another kind of design choice he made is he used the top down other than the bottom up, right? And I think for the most of these laser-based ones, the system usually adopts the top down than the bottom up. I think I remember one of you mentioned that could be because the reflection of the laser when you scan the pattern from the bottom up. Yeah, I think that could be a concern about that, about the design decision made here. All right. Okay, we can move on. So other kind of multi-additive process like the one shown here, basically it's kind of a combination of a fuse deposition modeling and this spinning process. As you can see, the material is spinned like in certain pattern and then add onto a substrate. And then it generates each layer by layer. So that brings the freedoms of the structure of the material by introducing the spinning process. And you can see some of the very complex shape structure like this could be generated using this kind of process. Yeah, it's kind of fiber. And some other process, actually this has been introduced when we talk about the those laminated process. Basically, this process utilizes the ultrasonic consolidation. Basically, it will generate the initial shape using the ultrasonic consolidation, and then applying a milling process to remove the actual parts, right? So it's the hybrid process for additive process and the subtractive process.
So have you?
Yeah.
I guess that's telecom, trying to figure out part of our target stuff. Have you ever had any deal with Fibersonic? Anybody else?
I mean, I didn't do any process with this, but I mean, from the concept, I think it's understandable. It shouldn't be problems. But to me, this process is quite limited in terms of the materials and also the mechanical properties for the final thing. Yeah. So that's yeah.
They're doing pretty well at aluminum, but
Yeah.
talking about stainless, it sounds like
Yeah.
they have issues with
Yeah.
their little
Mhm.
roller, ultrasonic thing, well, there's
Yeah.
But what we're looking at for the target is having better, fiber up strength gauges around the
Yeah.
target. Right now, the blue won't live in radiation.
Yeah.
So it sounds like it's talking to RNL on another project, they're embedding fibers with bracts for string measurements. Do the same thing with our fabric grill.
Yeah, actually for this kind of hybrid, I mean additive plus subtractive process, I have one concern. That is for the subtractive part. If there's internal structure or those cavities, so how could the subtractive process access those regions? It depends on the size and shape of the tool head, right? So not all the features could be manufactured using the subtractive manufacturing, because in the machine CNC machining process, there is limitation for the features, for the shape be processed using CNC machine. I think similar problem will happen to this kind of process. And that limits your design. So you could not design such kind of features in terms of shape and size, such that the subtractive process could not access. So any thoughts on this?
One thing they're doing
Yeah.
is they're actually doing this directed between passes.
Yeah.
So they'll actually lay some down
Yeah.
and then they just trim up the
Yeah.
edges and everything, lay another down,
Yeah.
trim up the edges again.
Yeah, but you want to be able to do
Layer
any,
by
like,
layer.
you want to be able to do any internal overhang that your tool can
Mhm.
have actual access.
Unless you
Well-
cut the layer.
Right, well, or unless your layers
Yeah.
were thin enough such
Yeah.
that,
That's
You
what
could-
they're doing.
Yeah, it can be very tricky, but.
So on one of their things they really are selling them are like things that have got formal cooling channels in them. And so what they're doing is they're kind of going there and laying, cutting the stuff and then just, it's really like strips of metal across, and just using the strips of metal to span across the welding on each side.
Mhm.
That's why we're finding for small spans. But
Yeah.
if you've got a big span and you're trying to roll over and create pressure to do that welding,
You don't have to weld it. Place to place.
I'm saying for a big span, though, you want to put 2 layers above a big span. You go to roll over this and you got 2 sheets that are just gonna get pushed down. because of
Yeah.
your contact.
I think the way for this process could, somehow release the restriction a little bit by performing the subtractive process per layer, right? If you have the overall shape, it could be too late to put your tool head there for machine part. But this is applied, the subtractive manufacturing is applied for each of the layer. So that could benefit for this planning. But theoretically, there should be still the limitation for some of the geometric features.
So if you could end the, like top down and then put the on the bottom.
Yeah.
You could keep moving, pre-cut your layer over there and then just keep moving, doing the layer you want.
So they don't use really thin strips.
But you really thin strips, right?
Yeah.
Kevin's point about you can't bridge because the material weight will go down, it disappears if you were to invert the product.
Kind of thinking off the top of my head,
Yeah.
but you can put like actual pre-cut tubing
Mhm.
channels and roll layers over the tubing, and it'll give you slope and bridge gaps.
Yeah, kind of.
Inserting a
Yeah,
tube or-
Kind of.
yeah.
Mm.
I guess that's still accurate.
And then, also, they can do multiple materials with this one.
Yeah.
Material
Yeah.
at the same time. And that brings up, I saw one time I was at a place and they were making these little tiny, microwave transmitters for satellite. They were super tiny and had to have all these ridges. So what they did is they actually cut the part out of copper, like the inverts, with all those pins, whatever, and they coated it with metal. And they just chemically etched out the copper. You could do the same sort of thing because you're only building solid and then just eat out the metal.
Melt it out.
No, melted with like acid, chemically or whatever.
Yeah.
bismuth.
Yeah.
Yeah, I think that this process has the potential to have some more development, but I don't know why there is not such variation yet. Maybe, what you gain will not justify what you pay for the complexity of the
Well,
process.
look at the benefits, AM, that you're not getting with this process, right? You have to buy a billet of material,
Yeah.
it's just that you're buying it in little strips, right? You still buy the same amount of material, so you're not like getting less weight.
Yeah,
You lose a lot of design freedom.
Yeah.
So, for designing for it, I wouldn't be very careful.
yeah, that's true. Yeah.
So the question is, for us, it was attractive because we weren't really gonna, I didn't want to additively manufacture material all through everything, but then I could take it apart and then just kind of embed stuff in it. Because I have a really big bed that's 6 feet by 8 feet kind of thing. And they can take it apart and then add, sheet it and then add parts to the outside.
I
Are there
see.
any other parts or other methods we could do similar
But
things?
you could embed things in.
But you can take a non-additive manufactured part and then
Yeah.
add.
in that.
So you're suggesting some sandwich structures. You embed one material into another material,
Yeah,
and then add on other.
So,
You can always do like hydrogen explosion.
Well, we do explosion bombs for proton stuff, but
Mhm.
if you want, trying to do it ahead of time. So this one would be good because we almost have a target complete. And then
Yeah.
we could add in the sensors at the last minute. That way we didn't have to have the sensors embedded during the whole rest of the process.
Do the sensors have to be mechanically attached to the rest of it, like are they string gauges? or-
Yeah, they're string gauge. That's what the problem we're having now is that they don't.
Don't you
They won't
remember
stay
the
attached.
reports of last?
I don't know what he's talking about. Battery furrows?
You
Pull that presentation up right now.
Yeah, maybe in like your case, you take your normal capsule and just do 1 or 2 layers of this kind of stuff. Just
Yeah.
encapsulating your sensors in that.
Yeah.
Like a 16th dimension, I think we're gonna cut little traces of blade fibers inside of.
Yeah.
Metal over the top.
I mean, you could take a conventional manufactured part and use this to finish.
Mm.
So do all your input to it, and then add your top coat. This would actually be a really good process if you wanted to add a corrosion resistant. If you wanted to add something non-homogeneous.
And it's cold. I mean, that's one good thing compared to the other additive manufacturers. We've got some like surface treatment on the target that can't get hot. But this one is like, it's just ultrasonic welding. Doesn't actually get hot before we're doing.
Pretty good.
Yeah, I think embedding fibers or some circuit or some sensors, which is not thick, will be a good application for the extension of this process.
But the heat removal, just take it apart and put in your channels for your heat removal and then put a foil of this on. I don't see it standing alone, but I see it usually.
But sometimes you have to justify because if the layer is too thin, then people will ask why you don't just use a coating, but a printing, right? So it's kind of always depends on the application, right? So if you are embedding some layers into an object, then it totally makes sense. But if you just have a few last layers for the project, for the object, probably you can go with code, something like that. Or the geometry is very complex, then go with. Okay, let's move on. Another process will be this direct laser deposition based process plus milling. As you can see, this kind of a curved like horn shape can be first deposited by this process and then fine-tuned by a milling process. And actually, I like this kind of process a lot because it has the multi-degree freedoms plus the multi-process. And to me, it's kind of the future directions for the process. So actually, it gives you a little idea about even for this kind of shape, although this is not that curved, but just imagine if you have an even curved shape, you could adjust the orientation during the deposition process such that you don't need to print the support material. And then after the printing, you could just use the milling process to fine tune it. And also not only for a direct laser deposition, but those WAMP process, similar concept. Although this accumulation of material could be different, but it shares the similar features. That is, it has multiple degree freedoms, and it requires the fine tuning. So basically, this kind of process is the one I'm looking at and try to kind of develop the a tool path planning as well as the slicing. As you guys did, I'm trying to make it non-planar, make it more flexible, and apply the same algorithms to different types of process who shares the similar features, such as multi-degree freedoms and multi-process. So any thoughts on this? I know some of you have looked at this direct laser deposition. Yeah, you guys can share some ideas.
So
Yeah.
One of the big concerns of this stuff is
Yeah.
you're limited by materials.
Yeah.
Because typically
Mhm.
these additive and subtractive
Yeah.
machines are just CNC
Mhm.
machining centers
Yeah.
that are converted over. And a lot of these, they have coolant in there,
Mhm.
so you have all sorts of
Yeah.
coolant. You can't recover any of your like the ones that use powder. You can't recover any of your powder. It's all wasted.
Mhm.
Any stuff you don't use. And I think because it's an oxygen-rich environment,
Mhm.
it's limited by materials.
Yeah, that's true.
The alignment issues between your direct laser head and what's doing that, and then your cooling.
Yeah.
It seems like you got the same sort of issues with the laser and the steel.
Yeah.
Well, you always will overshoot with the additive stuff because you're always removing excess with machining anyway.
Yeah.
So your final part is machine. You kind of always just overspray it a little bit and then you machine off anything that's over.
Yeah. So
But that leads to bigger heat.
yeah, I totally agree with you guys. Your points. Basically, the alignment could be an issue, and also the waste of material. Because after all, you have to machine your parts. And another difficulty, basically, I mentioned in last class is this. So you have to make sure what you have is always the superset of what you want. Right? If you have something is the subset, then you will have problems. You will never machine this to the final part. That means you want the deposited part, the additive manufactured part, is always larger than the desired part everywhere of the shape, such that you could eventually machine it to the desired shape. Otherwise, there will be the shape differences over here. So this is also another challenge: how to kind of plan your process, make sure this is going to happen, and how to align the two processes together. Apparently, it requires the precise scanning after you or other shape acquisition after you additive manufacture the rock shape, and then do the machining. And also, it depends on how accurate you want your part is, right? And that will determine what will be the accuracy for your shape acquisition, and so forth. For this WAM-based one, I think the most attractive points for this process is it could generate those bigger objects. And also, if we make the robots mobile, means it can move. And then some scenario like those mobile additive manufacturing could be the case. And for a big object, you could decompose it into different parts. And several robots will focus on one portion. And then as they can move, so they can do the assembly together. So it's like those ant or worm manufacturing. So you will deal with the collaboration with between different robots and different portions. So that's why this kind of process also attracts me. And actually, this setup is from Dr. Kim, and I'm teaming up with him, and I will focus on the planning and the algorithms, and he's building up his hardware test bed. So I think you guys also have a setup in the DML. So any thoughts on this?
I could see like a
Yeah.
bunch of like little swarm robots like
Yeah.
building an entire bridge. Like each of them has like a reel of metal and they just kind of do their thing and build the whole thing or something.
Yeah.
Wires, the wires.
Wires.
Because they never run out of the exact.
You know, you do a little black magic of artificial intelligence.
Yeah, get the other
You-
drone to get the, everybody else.
You throw you throw all the buzzwords in
No,
there.
I accidentally snipped that when I made the one up.
You throw all the buzzwords in there, and you know they magically do it.
You guys sit on the side and they watch the machine.
At some point, you'll short out your electrode model.
Yeah.
Well, yeah. Cost, rather.
Yeah, I think there are a lot of challenges still in this process because I mean, I recently I just saw Dr. Kim's first output for using this process. One part he printed using the robot and then fine-tuned by the milling machine. It looks pretty good, but still the geometry is limited, and also how to plan the building process such that there won't be any collision between the built part and the part to be built, right? These are also critical. Also the slicing, right? Again, slicing, right? How about some non-planar slicing, some more flexible process regarding this process. All right. Another example of additive plus subtractive will be this, well, FDM plus milling. But, well, I'm not a big fan of this because you can see, after all, it's something like this. After all the printing plus milling, you still have something you want to do some beautification on it. You want to do some sanding or other process on it. And yeah, go ahead.
I'm sorry.
Yeah.
That's some pretty crappy machine.
It's like,
It's done on a little hobby,
three
Robert.
toaster
But that's
strudels
the
smacked
problem with
together.
FDM, it's just crappy material.
So, yes, I actually have one of those in my garage, and it throws material everywhere. It's the dirtiest project in the world. The
Little
FDM
rockers.
stuff does not, and it destroys your bed.
As I said, from machining stuff from MDF,
Yeah.
from that big giant printer, that usually, you get into it, it's not as pretty on the inside as it is on the outside. So there's usually holes and voids and V-lands and everything.
You can probably pull a fiber too in your machine.
Well, yeah, I mean, but the fiber, you don't see a small little section. But,
Yeah,
their nozzle temperature definitely.
So one comment on these photos,
Yeah.
is that not a 3-axis milling machine that they're using to get rid of the staircasing effect? How they-
kind of.
Or,
Yes,
I mean,
that's what they're
so
doing.
they're just reducing the staircase size, right?
Yes, kind of.
Right.
Basically, it's fine to
It's better,
the part, but it's hard to tell it's better or not.
but having another
Yeah.
axis of motion might help get a better finish.
Yeah. I'd rather go other way to improve the quality than using this subtractive here. I mean, to me, it's more. It makes more sense if subtractive come in for this metal-based process than this plastic or polymer-based. So yeah, that's my idea about this kind of process. All right, I think we almost ran out of time. So next we are going to talk about the layerless additive manufacturing, and let's stop here. And thanks for your attention.
We got the video from last week. Now,
Pardon?
the video from last Thursday.
Yeah. I had that posted on iLearn. You can check it.
Okay.
I'm good for forever. My mother-in-law.
I got 7 minutes. And then I got to go back to